Welcome back, everybody, to Eadsy Astronomy. Time to kind of gather around the telescope again and just have a nice little discussion about our astronomer of this week. As we continue to progress down with the famous astronomers, we're going to take a look at Nicolaus Copernicus. Copernicus is a Renaissance astronomer who didn't just rethink the solar system, he repositioned humanity's place in it. His work laid the foundation for what we now call modern astronomy. He was the guy. He was born Nicolaus Copernicus on February 19th, 1473 in Torun, that's northern Poland. It was a thriving port city at the time. His family was actually relatively well-to-do. When his father died, when Nicholas was 10, his uncle, who was a powerful figure in the Catholic Church, became his guardian. His uncle would later support Copernicus's education and career in the church, while Copernicus himself quietly pursued his passion for astronomy. His academic journey took him from first to the University of Krakow, where he studied mathematics, astronomy, and philosophy. Later, on his uncle's advice, he went to Bologna, Italy, to study canon law, a path that was supposed to lead him into service in the church and a comfortable position within the Catholic Church. But while he was in Bologna, instead of focusing on the law, Copernicus focused on his passion, which was astronomy, studying the heavens far more than the law. It was during this time that he began working with the Italian astronomer Domenico Maria Navarra, observing the night sky meticulously. No telescope, just doing it visual eye, naked eye. Long before Galileo ever pointed a telescope up skyward into the universe. At that time, the prevailing model of the universe was the Ptolemaic system that had the Earth at the center of the universe, with everything else, the sun and the other planets, revolving around it. It was a geocentric view, had been accepted for more than 1,000 years. Copernicus, though, through careful thought and a critical reading of early astronomers, began to see inconsistencies in that system. And he asked the question, what if Earth wasn't the center? Here you can see the Ptolemaic system with Earth at the center, the moons going around it, then Mercury, then Venus, then the Sun, then Jupiter, then Mars, then Jupiter, then Saturn, and then you have the stars all on the outside of that. In 1514, he had written a small document called the Commentarius, the Little Commentary, in which he laid out an alternative, the heliocentric universe, in which the Sun, not the Earth, sits at the center, and the Earth itself rotates around the Sun. It orbits it annually. This simple shift in perspective explains the apparent motion of the stars, the cycles of the Sun, and even the planet's so-called retrograde motion as optical effects of our own motion. Here you can see his model taken from the book that started the scientific revolution, De Revolutionibus Orbum Coelestium. He correctly identified that Earth orbited the Sun as well as the other planets, and he got the planets in the correct order, with the last circle here representing the stars that were out there. So in the Ptolemaic system, if you look at that closely, if you go to the post over at Eadsy Astronomy on Patreon, you'll see that in that system, Earth is shown incorrectly closer to Mercury than Venus. In Copernicus's diagram here, we see the outer circle represents the stars, and then they move inward. They're Saturn, Jupiter, Mars, Earth with the Moon, Venus, Mercury, and Sol, or the Sun. So he didn't rush to publish his ideas. The times were cautious. Challenging Earth's centrality was not just a controversial science, it was controversial theology in that day. So he circulated the idea among close colleagues. One of those was George Joachim Rheticus, a young mathematician who became his pupil and champion. Rheticus helped push Copernicus to finally publish his masterwork. When De Revolutibus Orbium Coelestium on the revolutions of celestial spheres was finally appeared in 1543, excuse me, it was more than a new model for planetary motion. It was the starting point of what we would call today the scientific revolution. The book dismantled Earth's privileged cosmic status and placed it among the planets orbiting the sun in a vast ordered system. It wasn't perfect. Copernicus still assumed circular orbits, not the elliptical ones that Kepler would later establish, and his model wasn't immediately accepted by everybody. But it set the stage for Galileo, Kepler, and Newton, thinkers who would take humanity's understanding of the heavens to levels Copernicus could only begin to imagine. In Copernicus's own words, he said, quote, "Finally we shall place the sun at the center of the universe. All this is suggested by the systematic procession of events and the harmony of the whole universe." And that shift in harmony changed astronomy forever. Copernicus died in 1543, shortly after seeing his ideas in print. He devoted his life to science, the church, and public service. And while the heavens would eventually be mapped with telescopes and mathematics far beyond his reach, he was the first to put them in motion in a way that still shapes how we explore the cosmos today. He revolutionized the thought that Earth wasn't the center, sun was the center, the planets orbited the sun, and there was a whole universe out there. From him, people began to ask other questions and to look for answers. The science of astronomy really took leaps and bounds after him, and we really owe our modern astronomy to Nicolaus Copernicus. Thanks for listening. Stay curious, and of course, clear skies. Keep looking up. Talk to you later.